This is lesson 10-4, perimeters and areas of similar figures. Here's some review. What does it mean when two figures are similar? Sides are proportionate and angles are equal. We learned that when we were working on our unit on similar triangles. The next question is, are the corresponding angles of similar figures always congruent? Yes. Are corresponding sides of similar figures always proportionate? Yes. That's the definition we just wrote down. So in these last few, questions say circle the pairs of similar figures. So in number 4, we're looking at comparing our sides. So I see 2 matches to 3 and 2 matches to 3. And then I see an inscribed or an angle in here that is both 90. So by SAS similarity theorem, those two triangles are similar. And that was a review from before. But basically we know because these sides and this angle are the same that this third side would also have to be proportionate. In the second pair, 6 would correspond to 4, and the 4 corresponds to a 4, so this would be a no. And then over here we would get 6 to 8, 6 to 8, 6 to 8, and so on. So then our sides would end up being proportionate. From a previous chapter, we can look at our angles because we need to make sure our angles are the same. So both of these are pentagons. So if we do 5 minus 2 times 180, it tells me how many degrees are in there. And the 5 minus 2 tells me how many triangles are inside of there. So I get 540 degrees. And if this is equilateral, then all those angles have to be the same. And if the angles are the same in this pentagon, the angles have to be the same in this pentagon, which would make all the angles equal. So this would also be a pair that are similar. Here's the most important thing we look at today. Theorem 10-7, perimeters and areas of similar figures. If the scale factor of two similar figures is a to b, then number 1, the ratio of their perimeters is a to b, and the ratio of their areas is a squared to b squared. So that's what you have to remember. Sides and perimeters are a to b, and ratios are a squared to b squared. Number 8, the name for the ratio of the length of one side of a figure to the length of the corresponding side is the scale factor. And that's the number that we were just talking about, the a to b. The scale factor is a to b. Number 9, if the scale factor of two figures is 1 to 2, then the ratios of their perimeters is also 1 to 2. Remember, sides and perimeters are the same. Number 10, if the scale factor of two figures is 3 to x, then the ratios of their perimeters is 3 to x. It would stay the same. Number 11, if the scale factor of two figures is 3 to 5, then the ratio of their areas is 3 squared to 5 squared. So we would say 9 to 25. If the scale factor of two figures is 1 to x, then the ratio of their areas is 1 squared to x squared, which reduces to 1 to x squared. So make sure you remember that relationship today. The polygons are similar. Find the ratio unshaded to shaded of their perimeters and of their areas. So we start with the unshaded shape and we go to the shaded shape. So is this a shrink or is this an enlargement? I would say that this is going to be a shrink because we're getting smaller. So then our scale factor needs to be a number that we can multiply by 22 to make it smaller. So are we talking about 22 over 11? Or 11 divided by 22? Yes, 11 divided by 22. So we need to reduce that, and we get 1/2. So I'm going to make a table down here. This is for their perimeters, and this is for their areas. So the ratio of the perimeters is 1/2, because we take half of 22 to get 11, and then to get our areas, we would square both of those. So then I get 1/4. Number 2, we are going from unshaded to shaded. So this is an enlargement. So I need to get bigger. So 8 times some number has to make us bigger. So that means we're working with 10 over 8 versus 8 over 10. So I get 5/4 for the ratio of my sides. So the ratio of my perimeters is the same. And then to get my areas, I take 5/4 and I square them. And I get 25 to 16. Two similar polygons have corresponding sides in the ratio of 5 to 7. What is the ratio, larger to smaller, of their perimeters? The second question says, what is the ratio, larger to smaller, of their areas? So let's explore this question just a little bit before we answer it. It says, circle the similar polygons that have corresponding sides in the ratios of 5 to 7. So in this first one, it looks like our ratios are 5 to 10. So that's a no. Here we're looking at, we want to go from small to big, 8 to 14, which reduces to 4/7. And then here we go 10 to 14, which reduces to 5 to 7. So this is going to be the pair that we could use as an example. So back to the question. Two similar polygons have corresponding sides in the ratio of 5 to 7. What is their ratios of their perimeters? Well, the same. Sides and perimeters have the same ratio. What is the ratio of their areas? So now we use the formula 5 squared, 7 squared, and we get 25 to 49. The scale factor of two similar parallelograms is 3 to 4. The area of the larger parallelogram is 96 square inches. What is the area of the smaller parallelogram? So here's a sketch of what I think the picture is going to look like. We have a smaller parallelogram and a larger one. The ratio of their sides is 3 to 4, which also means the ratio of their perimeters is 3 to 4. The area of the larger parallelogram is 96 square inches. We have to find the area of the smaller, so I'll call that x. So we want to take this and turn it into a ratio that we can compare our areas with. So I'm going to square, and I get 9/16. So 9 over 16 has to be equal to the ratio of these areas. So 9 is the smaller, so x is going to go on top. 96 is for the bigger shape, so that's going to go on bottom. So if I divide x by 96, I should get that ratio 9 to 16. And now I have a proportion, and to solve this, I'm going to multiply by 96, because the opposite of dividing by 96 is to multiply. And I get 54. Our label would be square inches. The scale factor of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. How much should the larger piece cost? So our ratio here is 3 to 5, and that is for the scale factor. So that means side length. So this side could be 3 times some number, and this side would be 5 times some number. It doesn't have to be 3, it doesn't have to be 5. The cost of glass. Well, when we're buying glass, we're buying it in square feet. So this number revolves around area. So I'm not worried about my 3/5. I'm worried about the ratio that we use when we compare areas. So I want to look at my 9 out of 25. So the smaller piece costs $2.50, and the larger piece we don't know. So when I divide 250 by that number, I should get the same ratio. So I'm going to set up another proportion. So I have $2.50 on top, and our missing value for the bigger glass on the bottom. So again, to solve my proportion, I'm going to cross multiply, or I could get rid of my 250. So I'm going to cross multiply, and I get 9x equals 6250 divide by 9. And I get about $6.94. So we knew our costs should have gotten bigger by a ratio of 9 to 25. Otherwise, what we could do is just take $2.50 times 25/9, and that should turn into our $6.94 if we just apply our scale factor. Let's try another one like that. You want to carpet a room that measures 40 by 48 feet. An advertisement states that the cost to carpet a room that measures 10 by 12 is $216. What is a reasonable cost for the larger room? So our 10 by 12 is $216. Our 40 by 48 is what we're worried about. So if we look at our ratio of the sides, here's what we get. 40 corresponds with 10, 48 corresponds with 12, which we reduce to a scale factor of 4 to 1. So the 4 to the 1 is for sides, so we want to look at area because cost of the rug is going to depend on the amount of area we have for the rug. So my 4 over 1 I'm going to square, and that's going to turn into 16 to 1. So 10 times 4 gives us 40. 12 times 4 gives us 48. Now to get the cost of the rug, we wouldn't multiply by 4, we would multiply by 16. So we could just take 216 times 16, and that gives us $3,456 for the rug. Otherwise, you could set this up as a proportion. 16 to 1 is equivalent to x over 216, and it's the same process as what we did over here. Here's our last problem today. The areas of two similar rectangles are 1,875 square feet and 135 square feet. What is the ratio of their perimeters? Well, we can figure out what the ratio of the areas are. So 1875 square feet divided by 135 square feet. And my square feet label cancels. So then what I can do is, this is for my a squared to b squared. And I want to know what a to b is. So then I need to take the square root of that. So I get the square root of 1,875 over the square root of 135. And before I do that, I want to double check to see if this number reduces, and it should because they both end in a 5. And that gives me 125 over 9. So I'm going to put that over here. So now what I'm going to do is I'm going to take the square root of those, because those numbers are a little easier to work with. Because the square root of 9 we know is a perfect square. And then this, to reduce, we really get the square root of 25 times 5 if we factor it. So the square root of 25 is 5. And then we leave the 3. So this is our exact value for the ratio of the perimeters. We didn't just round a decimal and give some decimal answer. This is the exact value. So you do have to kind of remember reducing radicals in some of our problems today. This is the main thing that you have to remember today. Scale factor is a to b, and that means what is the ratio of the sides. The ratio of the perimeters is still the same, a to b. But the ratio of the areas, you have to square that number to get that relationship, because it is in terms of 2 dimensions instead of just 1. This concludes Lesson 10-4 for geometry.